This podcast is presented by HANNOVER MESSE, your leading event for industrial AI.
Hey, it's me, Robert. As you all know, we use the podcast to help our community find new jobs. Today, I have something from Heilbronn. And you all know that Heilbronn is one of Germany's industrial AI centers. Our listener, Professor Dr. Robert Alexander Windberger, is looking for a new colleague, a professor for resource-efficient IT and hard and software. You can find the whole job in the show notes. And now we will focus on battery testing. Enjoy listening. Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and my guest today is Richard Ahlfeld, founder of Monolith AI. Welcome. Greetings to London.
Welcome, and greetings back to you. It's nice to be here.
Richard, please introduce yourself briefly to the listeners. What is your profession?
My profession. Does founder count as a profession?
I'm not sure. You have to explain a bit.
So I think my background, I used to be in academia for 10 years. So I was in the UK, we call it fellow. In Germany, I think you might call it an assistant professor at Imperial College London. And then I did small research visits in Stanford and at NASA. So I think the best description of my background is a researcher for machine learning and engineering. And then my research became a company. And so since then, I've just been, a company director.
An entrepreneur, you might call it.
That expression, yes.
So we already had an episode with Monolith at the very beginning of our podcast. But today we are talking about batteries because, in my opinion, you shifted your focus. Battery is the new hot shit. Why?
I wouldn't say shifted.
Okay.
I'd rather say we sharpened our focus because, as you might know, our main product is a machine learning platform that allows any engineering user to build a machine learning model based on sensor data or other engineering product data. And people have been using that for all kinds of products really for the last 5 years. And what we've noticed gradually, I call this the monolith charts. Batteries have been moving up in the monolith charts year on year on year. And in 2023, they became the number one single that everyone wanted to listen to. And they've become so popular that we said, hey, look, the majority of new deals that we did in 2023 were all on batteries. And as you say, batteries are the hot shit, right? Like from battery cell manufacturers popping up left and right in Europe and the US these days, to new equipment suppliers, to new startups being built, to new battery test centers. We have a couple of solutions here that we've built for other purposes over the last years that are very unique, that are quite special, and they're very popular. And so we said, hey, look, it's the right time. It's really motivating. It's amazing to work on batteries. Let's really push this topic and let's see how far and how much we can help companies in this area.
Which pain do your customers have?
Okay, so the pain are there's various different forms of pain. I think if we start at the biggest possible, at the high level, then in the battery, in the current situation, there's a lot of engineering companies who haven't used batteries for their propulsion system in the past, and they now need to switch, right? And so they first come up against a very simple question, which battery should I use? And one of the things that is annoying about batteries is that it's very tricky to know how they will behave. You might have experienced this yourself with your smartphone, that it's very, very difficult to tell when the smartphone battery suddenly degrades. And I think we all have this moment after 2 years. I could have sworn yesterday I had a good battery and today I'm out at 2 p.m. Batteries have this very non-linear, sometimes random feeling behavior where they suddenly start degrading. And this behavior is very, very difficult to model and understand using physical systems up front. The only way you can really understand this behavior is by testing it, which is why all of the big European automotive companies are investing hundreds of millions in huge battery test centers and test labs You can imagine this as like a football stadium full of little boxes in which they put a lot of batteries, and then they cycle these batteries, like simulating literally on the hardware prototype, on and off and on and off and on and off. You, the user, using this battery on a daily basis, and they do this obviously thousands of times to see in what conditions, at what time does a battery fail.
So in the past, the cars were tested in Finland because of coldness and in the desert, and now we have also to test batteries on, off, right?
Correct. And it's funny that you mentioned sort of Finland and the desert, because
Yeah.
one of the things that makes the battery testing even harder is that like you also have to test them in different temperatures.
Sure.
And so there is battery cyclists that are just at room temperatures, and then there's battery cyclists, so battery tests that go at -10, -20, -40 degrees. There's battery tests that go up to 60 degrees. So you've got all of those thermal chambers where you cycle your batteries day on, day off in different temperatures, sometimes for years.
So this is one pain, the behavior, right?
Correct. Understanding the behavior is, I think, the root cause of what's going to create a lot of other pains. Because they don't simply understand the behavior, they need to go and test a lot. They need to test thousands of batteries in hundreds of different scenarios. And now this creates a lot of other problems. It creates the problems that it's very hard to decide which battery chemistry I can trust. Right? Like, it makes it tricky to pick the right battery because you can't quite know which specific battery is the best one for your problem. So you have to go and test them all. And the cycling also creates a lot of data. There are battery test labs of a large automotive company might create 2 terabyte of battery test data in a week. And then somebody needs to look at this data and figure out what it actually means. And then from this data, you obviously also need to derive how the battery behaves. You need to model it. You need to understand it. And so all of these different things is essentially created fantastic conditions for machine learning, because this is the kind of environment where, right, like, there's a lot of problems in engineering where you look at them and you think, why are you trying to use AI or machine learning? It's pointless. You have 5 data points and nobody knows what's going on here. You should just try and figure this out yourself. Here, we have hundreds of different batteries being cycling, creating terabyte of data in a space that is very hard for any normal person to understand because it's incredibly nonlinear. To make predictions for what millions of people are going to do with their car every day, it's perfect.
When we first talked at the Siemens conference, I think your marketing slogan was test less. So still the approach, test less.
Correct. It's still about testing less. And I think the reason why we gained momentum in the battery industry is that since 2016, we've been developing a toolbox, which the internal expression is it's our active learning toolbox. To explain it to people, we usually call it a test plan optimization toolbox.
Okay.
What this essentially does is that when, as a battery cell manufacturer or an automotive EV manufacturer, you come up with your plan of like, okay, this is what we want to test. Here's our long list of ideas. We want to test these temperatures, these cycling conditions, these driving conditions, these voltages, and so on. So you come with your long list. What this test plan feature does is essentially it goes through the list while you start testing and starts figuring out which tests do I need and which tests do I not need. So it might tell you when you start testing after 3 months, you can stop test 27 to 50 because I think you don't learn anything from those. They're useless. You can save your money. Instead, test 1, 7, and 50. Right? Like, those are amazing. Please double down on them. You should do more tests in a similar condition because I think we're learning really important things here. And so it's learning and it's working actively with a test engineer to figure out what to test, to learn more, and what to test less because they're not learning anything.
How you do that? Let's take a look under the hood. What do you do technically there in your platform?
Okay, it now gets tricky because mathematically there's a variety of different methods that you can do here. So the field of active learning within machine learning is in principle the entire field of using an existing data set and trying to infer from that what you know about it and what you don't know about it.
Yeah.
And there's a lot of fantastic papers in the battery industry where, for example, using Bayesian inference, people have been able to come up with what the optimal charging strategy is, or what the optimal discharging strategy is, or the optimal battery calibration. Anyway, so there is a long list of such algorithms, from clustering to random forest disagreement to gradient-based kriging to some forms of reinforcement learning, that essentially all are algorithms which look at a set of experiments and try to figure out what you've learned from those experiments in order to see what you should potentially do next. When I explain it internally to sort of new starters at the team, I usually tell them, do you remember, I think maybe 5 or 6 years ago, there were these type of algorithms that learned how to play Super Mario.
Yes.
And they learned how to play Super Mario basically just by a trial and error. Like no real intelligence, but essentially just trying to play and jump, and learned, okay, if I run into a rock that's bad, I need to go and try it again. And they learn by trial and error. And this is this class of algorithms which essentially gets rewarded for doing it right, and it gets punished for getting it wrong, and it just keeps playing and playing until it gets it right. So we use this kind of algorithm class, so like self-learning models.
So it's a reinforcement approach, right?
In principle, yes.
Yes.
Although reinforcement learning for some of the problems that have little data tends to be too inefficient.
Yes.
In principle, I think the best way to understand it is by comparing it to reinforcement learning, even though that doesn't work for all problems. But then, yes, essentially what the algorithm in the background does, it's trying to learn the game of how do I test my battery so that my company can understand how to use it in all different conditions as best as possible in as little time as possible. And so by giving the engineers who have to test these algorithms as support, it becomes essentially from trying to sort of play this game all by yourself, which is hard. You suddenly try this game and you have a chess computer helping you, right? And so if you've ever tried to sort of win against a chess computer, it's very hard to beat a chess computer at chess unless you have a chess computer yourself,
Yes.
right?
Yes.
What I find amazing, and we've seen this more and more throughout this year, when we've given battery test engineers this machine learning, it's not a bot, but like just this recommender algorithm to figure out their test plan, that they were first very skeptical.
Mm-hmm.
Because they're like, well, I've done design of experiment in university, and there's a D-optimal design, and you determine the determinants and so on. This is how you normally do it. I don't think this algorithm can actually be any better. And to be honest, I think 3 or 4 years ago, I would have told them they are right. But there's one thing we've done with the algorithm since then, which actually makes it very, very useful for test engineers. And that is, we calibrate it. So what we've done is that normally, I feel like most large engineering companies will say, we've tried this sort of active learning, and it doesn't tend to be much better than our engineers. And that is true, because there's too many different algorithms. And these different algorithms, if you put them on a new problem by themselves, they're not going to solve it. If you and I start now using a reinforcement learning algorithm off the internet, or let's use a random forest disagreement sampler, or anything else, and put that on a battery test, and compare that against an engineer, it's not going to be better.
Yeah, okay.
Because it's not smart enough. It hasn't learned enough. So what we do is pre-training. So what we've essentially done, we've collected data sets of battery test plans over a while, and we've built a toolbox that essentially goes through all possible algorithms and starts calibrating itself. So
it's an AutoML tool.
A little bit, yes. So we've essentially decided we're not training a model for your battery test.
Yes.
We're training a model that learns how to best predict battery tests. We're basically training the chess computer before it starts playing. So like it's a pre-trained model that has already learned how to play this game of battery testing for a lot of different batteries. And so when it comes into the game, it's not the first time it sees this. And as a battery engineer, thinking, well, this is dumb. It suggested that I start with room temperature. But essentially, right, it already comes with a suggestion of 15 to 20 points where you're like, that's pretty clever. It already from the start knew in what conditions this battery is going to degrade faster in a way most experts don't fully understand. So there's something clever at work here, and the next 5 steps are pretty good too. So we've essentially built a toolbox that we now have some collaborations where we get a lot of battery data sets. So we've hoovered everything in.
Yeah, that was my question. Where do you data gathering for the batteries?
Yes, so we've hoovered everything in. We have a collaboration with NASA. We've just signed one with an Imperial College spin-off, similar Imperial College spin-off asked about energy. And their business model is to go and test batteries for companies and then sell the test data set. So they have a library and then our partners. And then we have further collaborationships with other of the test stand providers in Europe. One of them will become more public, I think, in Q1 next year. So step one, gather a lot of the different data sets so we can start pre-training and making sure this works up front. And then the second part is that we still retrain the model when you come with your own problem. And this is important.
Okay.
Because battery chemistries change. And this is, I think, an important step because, right, like just because I've learned on a chemistry that was popular 3-4 years ago.
Yes, absolutely.
Doesn't necessarily mean I can generate, like the same battery is not always going to behave the same way. And so when you come with your, I don't know, what's the most fanciful thing that currently is like a solid state battery, like a lithium ion tuned algorithm is not going to give you the best predictions for solid state. So what we do is that essentially in our software now, we have this evaluator function where the person who wants to build a solid state battery can take our test plan optimizer algorithm, upload all of the data that they so far have for their solid state battery, and then the algorithm starts calibrating itself again, trains itself, plays this game thousands of times against itself, and then comes up with recommendations of what to test.
So, Richard, do you sell now a toolbox or is it a model? What would you say?
It's a toolbox.
Okay.
Because it's still a lot of things. The model itself, we're obviously selling basically both. But the toolbox is, I think, essentially the part that the engineers need. Because a model in itself is not as useful if you don't use it for something really valuable, like validating which tests are useful, in figuring out what tests you really need to do to improve the thermal safety of the battery. And so there's like a lot of different tests and a lot of different applications that you might use this for, right? Like from how many charging cycles, what is the best way to cool the battery, what's the capacity, what's the life of the battery. There's so many different things that this algorithm could be doing, and it needs to be tuned for all of those different things. And so what we've done is we've built this toolbox which allows the engineer to essentially say, hey, I want a learning algorithm for the aging. I want a learning algorithm for the safety. And what is unique about this approach, and I think that was making it so popular, is I think everyone in the battery industry right now is focusing on building a model of the battery itself.
Yeah,
all
exactly.
of these startups, and like their main focus is, I will have to build a model of the battery.
A big model, yeah.
Correct, right? We, on the other hand, we're essentially saying, I want to build something that is primarily focused on helping you build the model. So we're not competing with people who are saying, oh, I'm going to build a model of the battery. It's like, yes, please, you should do that. And you should probably go and make that a physical model too, and not an AI model, because physical models are interpretable. But before you get your physical model, you will have to go and test some batteries to validate that it's actually true. That'll cost you a lot of time and a lot of money. And so either way, you have to get this testing done as fast as possible. And then you have to figure out what tests you need to do. And this is the only tool that actually helps you figure out what test in what sequence for how long you need to do in order to get there. So it's essentially, no matter what approach you use, physics modeling, machine learning model, hybrid model, it's accelerating how quickly you get towards having, it's accelerating the time you need to get any model of your battery.
This toolbox, do you deploy it on the edge or on the cloud? Because you mentioned 100 million euros in test facilities. It's an area where the automotive companies and the first tier suppliers are very nervous. So it's an edge-based design, or is it a cloud-based design?
At the moment, it's a cloud-based design primarily. The data sets that come off most of the large battery labs, you're right, they are very, very confidential. Highest security, and it's a very confidential area overall. But given the size of the data and the processing needs, and the fact that most large automotive companies have realized that eventually they need to have the capability to analyze the data on the cloud. Because if you look at Tesla, one of their main competitive advantages is that they get information from all the batteries from every user back every second.
Mm-hmm.
And that kind of information gives you so much insight into how you can design better batteries. And you can't just do that, right, like purely on the edge. That I think there's common understanding that you need to have a proper cloud-based solution to analyze your battery data. And so you might as well start that with your battery R&D test data, in particular, because it's pretty large, right? We're talking about huge amounts of battery test data that come off these huge facilities now. And so, yes, it's all cloud-based.
So what does the customer have to do? How do you integrate into the process of your customer?
Mm-hmm. So let's see. If you wanted to basically just run a pilot, then it's on an Amazon Web Service cloud, into which whether you use an API or anything else, just push your test data. In production, it depends a little bit on what kind of test stand equipment you use. For example, we really like working with National Instrument, who have a enterprise architecture called System Link, which basically is something that has all of the test systems locked in and pushes all of the data essentially into some sort of cloud solution. So there's a variety of test providers, Keysight, National Instrument, who run these massive battery test centers. And their job pretty much is, and that's why we like working with them, is to get the data into some sort of cloud or SQL database. And then we pick up the data from the web server and then help users figure out, right, like what the optimal test plan is.
And you mentioned data gathering is not the problem in this approach, right?
No. In batteries, as you know, I've worked in a lot of different engineering areas for the last 5 years. And normally, if you ask me what is the biggest problem, I would immediately shout data gathering. In batteries, we're all gathering battery data every day. Our laptops, our phones, it's quite cheap and easy in some sense to gather battery data, because there are sensors on them and you just need to go current in, current out, temperature. Controlled conditions are harder, so it's very easy to get a lot of battery data. It's much harder to then figure out, what do I actually do with it?
So what are your next steps? So you're now in this battery market. Maybe we have a call in 2 years again. Are you still in the battery market, or do you see other markets?
So for me, the vision behind Monolith hasn't changed at all. For me, batteries are just an amazing example of where the whole story comes together really, really nicely. And so whenever I talk to any potential client, or I will draw up a story from you design your product, you simulate it, you test it, you manufacture it, and you put it into market. And all along this journey, right, there's the same steps that engineers take, right? Like they have to figure out a test plan. They have to come up with a model. They have to figure out the root cause of specific issues that they've had with their product. They need to validate that their data is true. In these specific use cases, they are completely identical, whether I'm building a rocket, an aircraft, a shampoo bottle, or a battery. And I think for me, this has been one of the biggest learnings at Monolith of the last 5 years, is that there's R&D of products has the same problem statements and pain points, and that you can build machine learning solutions for each of those pain points, and they really scale across the different areas and industries. And so for me right now, battery is just the one where there's the most interest in the market, and where we as a company are really motivated to just help it because of the climate change implications and the environmental impact and the fact that we need more ethical batteries. Like, we're very motivated to take batteries as a specific area and just push it forward as fast as we can. But what I'm trying to say is we want to, in the next, let's say, year or two, want to build out the perfect solution for batteries, where a battery R&D team can, from design to in the field, can learn from all of the battery data sets along the way and solve all of the problems that can be solved with machine learning, right? That's our focus. And then the same use cases, we've already applied them to fuel cells, hydrogen fuel cells. We have a couple of hydrogen fuel cell examples. So I don't know what the next exciting thing will be. I think batteries will be hot for a while, but the same use cases and I've seen this again and again over the last 5 years, they really apply across industry verticals and across different products. And you find them again and again. And the vision behind Monolith is and remains building a platform that allows research and development engineers to get access to these machine learning toolboxes to go and validate their data, figure out the root cause, optimize their test plan, predict the result of a complex system and an unknown vision, come up with a model. These different things, they are pretty universal.
Richard, thank you very much. It was a pleasure. All the best and take care.
Thank you, Robert.